Maybe you've read or heard about these, or perhaps you've heard or seen words like these. This course is about all of these and then some. Welcome to Analytics and Predictive Modeling, a course on big data. I'm Dr. Jeff Nicely of the Cards Institute, and this course is part of their new data science program. We're familiar with these sorts of things in our modern society, and they each depend on these kinds of concepts. And all of those are related to big data. See, we are in the midst of a revolution. Algorithms are everywhere. Many of the most important algorithms are less than 20 years old. Google's PageRank algorithm, recommender systems. New algorithms are occurring practically every day. Data sets are large and they're getting larger. The Large Hadron Collider produces more than 6 million gigabytes of data every second. Social networks, Twitter, systems biology, all examples of big data. We're in a big data revolution. Nearly 100% of the world's data has been generated in this century. In 2012, there was an average of 2.5 quintillion bytes of data generated every day. There is 2.5 million, 2.5 billion, 2.5 trillion, 2.5 quadrillion, 2.5 quintillion bytes of data every day. Most of it is big data, enormously large data sets. Much of it exists only briefly, quote, in the cloud. Each of us individually generates several megabytes of actionable information every day. The cloud collects it, processes it, returns results to us in real time. That's how we get live traffic updates, for example. So what is big data? Well, big data is so large and so complex that it's difficult to process with traditional methods. Data scientists tend to use the 3 V's: high volume, high variety, and high velocity. So why bother? Why not just stick with old-fashioned data sets and the tried and true statistical techniques from the past? Well, big data is also very good data. Data that allows us to answer questions we could only dream of even thinking about a few years ago. Self-driving cars, precision agriculture, personalized medicine, personalized learning. But big data requires new models and new methods for working with this data and making reliable predictions. So analytics, meaningful patterns in the data, and we get inferences from the data to make a decision. And this is often called actionable information. So the movie Moneyball is all about analytics in sports, medical diagnostic testing. So this is one way to get information from big data sets. Another is to use what are called predictive models. They're the mathematical models that a machine learns, the ones you use in machine learning. Algorithms that are designed to make predictions, and algorithms that learn from the data. It's a subset of artificial intelligence. Analytics and predictive modeling is sometimes called machine learning in computer science, predictive analytics in commercial contexts, and there are many other names, and it's also closely related to the data sciences. Data science tends to be the application of convex optimization and numerical linear algebra to big data. But much of what we do in data science is via predictive modeling, even though analytics and predictive modeling is mostly based on calculus. Well, you might ask, aren't all models predictive? Well, let's look at a comparison of the two. So descriptive models You make mathematical assumptions about a process, law of universal gravitation, constant per capita growth rate. Then you get a model that you derive from these mathematical assumptions. You end up with conclusions like orbits are elliptical, and ellipses can be represented by equations. Growth is exponential, modeled by an exponential function. You obtain data, you estimate any parameters in the model, and then the predictions are actually interpretations of the solutions to the model itself. In contrast, in predictive modeling, you begin with complex data sets that may be incredibly large. You ask and refine questions. What genes are related to a given cancer? Is growth ever exponential? You've got a set of data. Is there any place in the data where you actually observe exponential growth? You apply algorithms that predict answers to such questions and assess the results. Very, very important. So the role of big data is that modern data sets tend to be very large, very complex, and again, very good. Descriptive models and the use of equations just simply cannot extract good amounts of information from these big data sets. Predictive models are algorithmic models that extract information quickly and effectively. We'll see some examples of why it has to be quickly later on. And it produces results that we can rigorously evaluate. So the predictive modeling approach, this is what we're going to develop in this course, is the idea that you first explore the data. I mean, it could be possible that you could simply look at the data and obtain an answer to a question you might be interested in. But then you'll probably want to pre-process the data, transform it, especially if there are some features that are dominant. Maybe we want to change so we have dimensionless data, no units. And then we use the data mining allegory, which is that we can separate valuable information from the rest of the data. In other words, there is information in the data and we can find it. And then, of course, we have to assess the results. But this course is not primarily about big data, nor is it primarily about predictive modeling. You see, mathematically, artificial intelligence, for all of its flair and people reacting with fear, artificial intelligence is really just a little more than a modern interpretation of calculus. Classical calculus is what allows this course to go as far as it does. You may say, I have no coding experience and no background, but you've completed a calculus sequence. Well, that's the background we need, because in a lot of ways, all we'll be doing this semester is reinterpreting calculus. In fact, if we had modern calculus along with modern linear algebra and some coding skills, we could do pretty much all of data science. Now, that's why when I teach Math 5016 Applied Math 1 at the same time as this course, I introduce the modern linear algebra necessary for the data sciences. Can't do everything in one course, and so I can do everything in this course that's based on calculus, but then if you want to see more, things like convolutional neural networks, autoregressive methods, you would have to have some linear algebra background, and I do that in the Math 5610 simultaneous to this course. But there's a lot you can do with just predictive models. For example, IBM Watson beats the Jeopardy legends. How? Well, Watson had to learn the subtleties of the questions, the nuances of the English language. Yahoo uses an algorithm called MapReduce, which reduces documents to individual words and determines how these words imply sentences and sentences imply paragraphs, so on and so forth. And Yahoo claims that practically every web page they've ever produced is produced using MapReduce. And many other companies use this algorithm as well. So there are a lot of things going on and a lot of applications of the things that we're looking at far beyond even probably the most obvious ones. But before we do anything else, let's look at the structure of the course that we're about to embark on.